The night before. A 20-year-old scribbles feverishly by candlelight. In the margins, again and again, I have not time, I have not time. May 30, 1832. Shot through the intestines, he lay dying for hours before a peasant found him. His last words to his brother, "Don't cry. I need all my courage to die at 20. Welcome to Men of Mathematics. Today, in Part 7, Tragic Geniuses, we meet Evariste Galois, the revolutionary, born 1811, died 1832. Last time, we met William Rowan Hamilton, who discovered quaternions in a flash of insight and spent decades developing Hamiltonian mechanics. We saw his linguistic genius and his later struggles. Evariste Galois was born October 25, 1811, near Paris. His father was mayor of Bourg-la-Reine until political enemies drove him to suicide. Young Evariste was a passionate Republican in a time of political upheaval. At 14, Galois read Legendre's geometry textbook, meant for 2 years of study, in 2 days. He then devoured Lagrange's work on equations. By 17, he was producing original research. He failed the entrance exam to the École Polytechnique twice, once, legend says, because he threw an eraser at an examiner who asked a stupid question. He submitted papers to the Academy of Sciences. Cauchy lost the first one. Fourier died before evaluating the second. A third was rejected as incomprehensible. Galois was imprisoned twice for his Republican activities. Upon release, he became entangled in a love affair, possibly a setup by political enemies. A duel was arranged. When can a polynomial equation be solved by radicals, using only addition, subtraction, multiplication, division, and taking roots? Abel proved the general quintic has no solution. Galois answered the deeper question: which specific equations can be solved? Galois' insight: the roots of a polynomial have symmetries. Permuting the roots in certain ways leaves the polynomial's coefficients unchanged. These symmetries form a group. Galois' theorem. An equation is solvable by radicals if and only if its Galois group has a special structure. It is solvable, meaning it can be built from cyclic groups. The symmetric group S5, all permutations of 5 objects, contains the alternating group A5, which is simple. It has no proper normal subgroups. This means S5 is not solvable. A general quintic has Galois group S5. Therefore, no radical formula exists. Galois didn't just solve a specific problem. He invented a new branch of mathematics. Group theory now pervades algebra, physics, chemistry, and cryptography. The structure of fields, symmetries in quantum mechanics, molecular symmetry, elliptic curve cryptography, all rely on Galois' ideas. May 29, 1832. Facing death the next morning, Galois wrote through the night. He summarized his theory, added marginal notes, "I have not time," and addressed his manuscript to his friend, Auguste Chevalier. Galois wrote to Chevalier, "You will publicly request Jacobi or Gauss to give their opinion, not on the truth, but on the importance of these theorems." May 30, 1832. Galois faced his opponent, possibly a fellow Republican, possibly over a woman, possibly a political assassination. The exact circumstances remain mysterious. "Don't cry. I need all my courage to die at 20. These were Galois' last words to his brother Alfred. Galois' manuscripts were published in 1846, 14 years after his death. It took decades more for mathematicians to fully understand what he had done. Joseph Liouville recognized their importance. I hope to publish this work in a form which will bring out all the clarity of these profound ideas. Today, Galois theory is fundamental to modern mathematics. The Galois group of an equation or field extension is studied in every advanced algebra course. Galois himself is a romantic figure, the doomed genius, the revolutionary, the mathematical rebel who died young. I have not time. Those scribbled words haunt mathematics. What might Galois have done with even a few more years? He saw further into the structure of equations than anyone before him, and had no time to explain what he saw. As E.T. Bell wrote, Galois was the most romantic figure in mathematical history. In a short life, he accomplished as much as any mathematician has ever accomplished in any lifetime. Next time on Men of Mathematics, James Joseph Sylvester, the man who invented matrix theory and named half of modern algebra. His colorful vocabulary, his bitter feuds, and his remarkable creativity make him one of mathematics' most vivid characters. Thank you for watching Men of Mathematics. Subscribe for new episodes every week. Next, James Joseph Sylvester.